New observations from the James Webb Space Telescope, JWST, are shaking the foundations of physics as we know it. For decades, the Big Bang Theory has been the dominant explanation of how our universe began and evolved. But with the telescope's latest discoveries, that long-standing view is being questioned. One recently captured image has sparked intense debate among scientists, providing such powerful evidence that it's forcing experts to reevaluate some of their most trusted assumptions. The photo isn't just beautiful, it's a game changer, hinting at mysteries that could completely transform how we understand the cosmos. The image, taken deep in space, brings fresh perspective to one of the most hotly debated issues in astrophysics. How old is the universe, and how fast is it expanding? For generations, scientists have tried to pin down these answers, using various tools and methods. Cosmology, the science of the universe's origins, evolution, and eventual fate, has advanced rapidly over the last century. The prevailing theory, known as the Big Bang, suggests that the universe began about 13.8 billion years ago, from an incredibly dense, hot state. Since then, it has been expanding, a process measured using something called the Hubble constant. But here's the catch. We don't have just one way of measuring the Hubble constant. We have two. One approach uses nearby objects, such as certain types of supernovae that always shine with a consistent brightness. These standard candles help astronomers determine distances in space. The other approach looks far deeper into time, using the cosmic microwave background, CMB, a faint glow left over from the early universe. Discovered in the 1960s, this light carries the story of when the universe was only 380,000 years old. The problem? These two methods don't match up. Local measurements suggest the universe is expanding faster than the CMB readings would indicate. This discrepancy, known as the Hubble Tension, has puzzled scientists for years. It hints that either we're missing something big or that one of the methods is flawed. That's where the James Webb Space Telescope comes in. With its advanced infrared vision, it allows astronomers to see farther into the universe and further back in time than ever before. Researchers hoped this would finally settle the debate. Instead, the first wave of data has only deepened the mystery, showing even more inconsistencies. This new information might mean that our entire model of the universe needs an overhaul. There could be unknown particles or forces at work. Dark energy, the strange force thought to be accelerating the universe's expansion, might not behave the way we thought. And the nature of dark matter, another invisible component that makes up a huge portion of the cosmos, could be very different than we assumed. Let's not forget the historical significance of breakthroughs like these. When the CMB was first discovered in 1965, it offered strong support for the Big Bang Theory. Before that, many thought the universe had existed forever in a steady state. Then, in the late 1990s, astronomers found that the universe's expansion was actually speeding up, a discovery that introduced the concept of dark energy. Each time we uncover something new, it challenges old ideas and forces us to rethink everything. That's the beauty of science. It's constantly evolving. Another concept tied closely to the Hubble tension is what's called sigma tension, which deals with how matter is spread throughout the universe. In some regions, galaxies bunch together in huge clusters, while in others, space is almost empty. To map these patterns, scientists use gravitational lensing, when massive objects like galaxy clusters bend the light from objects behind them. This lets researchers detect dark matter, which doesn't emit light and can't be seen directly. They also study the CMB to get a snapshot of the universe's earliest structure. But again, there's a disconnect. The uniformity seen in the early universe doesn't quite match what we observe today. That mismatch could be a clue that there's a missing piece in our cosmic puzzle. Dr. Adam Rees, a Nobel Prize-winning astrophysicist, recently shared his team's findings with a leading astronomy journal. They hoped the James Webb data would clear up whether earlier measurements, like those from the Hubble Space Telescope, contained errors. But surprisingly, Webb showed the same discrepancies. That consistency across instruments only adds to the concern. Somewhere between these results lies a fundamental misunderstanding of how the universe works, Rees explained. The telescope's precise infrared imaging lets scientists measure cosmic distances with incredible accuracy. It opens a new window into the unknown, giving researchers more tools than ever to track how galaxies form and evolve. Yet dark matter and dark energy, the two mysterious components that dominate the universe, remain elusive. While black holes were once thought to explain some strange gravitational effects, attention is now shifting toward how these hidden forces might influence the universe at large. It's a thrilling time to be alive, especially for those of us who have watched science evolve over decades. Every new discovery is a reminder that the universe still holds many secrets. As we continue exploring, we might not only reshape our understanding of space, but also our place within it.